This is TWiT.
We've got Leo's Tesla in front of us.
We've turned into giants. That's what really happened.
Okay, so this is not, this is Leo's Tesla, but it's not Leo's Tesla. So he got this a while back because he was one of the first to get the X, which he enjoys driving around. This is obviously built for children, but this is TWiT, so we've been driving this thing around, and I think we've kind of bent out the wheels a little bit.
What are you gonna do? It's begging to be ridden. And
the maximum weight on this thing is supposed to be like 60 pounds.
I didn't know that one day, and I tried to fit into it, and then I was like, wait a minute, there's no way this is gonna work. Thankfully, it didn't, because then I found out about the weight limit.
Believe it or not, I actually fit in it as long as I straddle the outside.
Yeah, if you sit your butt here and your legs hang out on the sides, then
I kind of had to reach down to activate the pedals, but you know, it's cool. It's cool.
It's a hand pedal.
No, we got this a while back, and it's been fun. It's been sitting outside of Leo's office. We actually have a couple of kids who have ridden in it, and they don't like it because it's kind of rudimentary. It either goes or it stops. There is no varying grades of speed.
Well, you can. Well, yeah, that's true. Yeah. I see what you mean. Speed-wise, you can still steer it and everything. But.
So what we thought we would do is we would actually turn this into something else. And we're going to need the soldering skills that you just learned, because we're going to make this a remote control car.
What?
Yeah, it's actually got everything in here that we need to make it a remote control car, except for 2 sets of components. Now, if you go ahead and open up the back there, Jason.
I don't know if I can around these jetpacks. What are these things?
The rockets, I mean, come on, that's when you need to go really fast.
Okay, or into space.
Yeah, you can go ahead and pull the battery pack out of there, because what you see is that is a 14-volt LiPo cell that's inserted into the back of the car. Yeah, there you go. See? That thing. Now, the nice thing about this is that's going to provide me 14 volts, and the speed controllers that I'm thinking about putting in here can typically handle anything from 7.2 all the way up to 16 volts. So this should be well within its range. And it's got its own charging system, so I want to use as much of the original parts as possible. I don't want to turn this into a remote control car by strapping on a bunch of remote control components. I actually want to use the components that's there. Now, knowing that that battery is there, and knowing that the foot pedal turns on the motor, and knowing that this controls forward or reverse, go ahead and take a look in here. You run the camera. There you go. See, so that switch right there, that controls forward and reverse. And of course, I've got the horn, which I can activate, but I'm not going to do it here. It allows me to kind of think about how they've wired this. I go from the 14-volt LiPo pack to the forward or reverse switch. So that will determine which way the current is flowing. It's just a two-way, two-pole switch, so I can either send it positive, negative, or negative, positive. And depending on which way it goes, it's going to make the car go forward or back. Then there's a foot pedal that is basically just an on or off switch. It's a momentary switch, which means I can either go full speed forward or full speed back. Now, this right here, this is an entirely mechanical steering. And unfortunately, if you get a shot of this, Jason, you know, the wheels out here, it's not a great turning radius, and there's not a good way to fix that. So this is going to be a very limited remote control vehicle. Yeah. Unless I want to.
It's not a very nimble remote control
vehicle.
No,
no. But that lets me know that there's a certain way I'm going to have to design this. Now, let me take this off. Get a shot of that, Jason. Inside, this is the powertrain. So I've got 2 motors, one driving each transmission on either side. Now, the motors are actually reverse wired from each other. So when one motor is spinning clockwise, the other one is going to be spinning counterclockwise in order to make the vehicle move forward and back. Now, this is good, though, because it means that I can actually, since I know the steering up front is going to be so bad, I can use differential thrust. I can actually have one wheel turning faster than the other so that the car turns a bit better than just the steering. Right?
Wait a minute, they're not locked together?
They're not. Well, those are independent transmissions. So those are two motors.
Well, that gives you a lot more capability then.
Yeah, yeah. So here's what I need. I need a way to control the motors, and I need a way to turn the wheel. Now, the wheel is actually really simple. I just need a powerful servo. This is a 20-kilogram servo. This is a DS3218. It's full metal, so all the gears inside of here are metal, which you're going to need because if they're plastic, they'll strip. And it will allow me to put 20 kilograms of force through the range of this servo. This is about 19 bucks, so this is inexpensive. The only question is if I mount it here or if I mount it underneath the car near the transmission. I'm probably going to just mount it underneath just so that it keeps this nice and clean. I'd like to keep it so it looks stock.
Right.
Right. Then I only need one other component, and that other component is the ESC. We've seen these before. I've used a lot of them on the show, and unfortunately, I'm not going to be able to get it out of this bag. Or maybe I will. There we go. No Mylar is safe from me. So what this is this is a 320 amp, 7.2, 16 volt brushed ESC. Brush is important because these are brush motors. There's only 2 poles rather than 3. This will allow me to control both of those motors. So what I'll be able to do is I'll be able to wire that up to a standard receiver, because these are both just remote control standard, PWM. I can wire it up to a standard receiver, and it will allow me to use a transmitter, an RC transmitter, just like I would on any other remote control car or a quadcopter. In fact, it's going to be the same remote, same transmitter as the quadcopters. And since I have so many channels, what I'm probably going to end up doing is I'll be able to control the direction of the car with one stick, and the other stick will control a camera. Nice. So that you can drive this thing FPV.
Almost like driving a real Tesla.
Almost.
So close.
Right. And actually, Chumley in the chat room, he obviously has seen these before because he knows that those are 540 RC motors. And this was, again, it was only designed for someone up to 60 or so pounds. So there's not a lot of oomph, but imagine this being able to drive itself without those 60 pounds. We're going to do damage.
Yeah, or we could put like a very small dog in there, and it'll seem like the dog is driving.
He's not down with me, but I'm thinking this would be the perfect baby stroller for Patrick Delahanty. Right? I mean, come on.
And if you could work in the technology that you have in drones that auto follows you, then Patrick's just walking downtown in a little Tesla with his baby is following him.
Although if it glitches and it starts following somebody else.
Bad idea. Never mind.
You've just kidnapped. Self-kidnapped.
Control Z on that. I apologize.
So we're going to be working on this. This is actually a project I'm going to be doing for the new screensavers, but it was too much fun. When I couldn't believe that Leo said, yeah, go ahead and cut it up. I'm like, really?
Hey, what else is it going to do? It's just going to keep collecting dust.
At know-how, no expense is spared. We will even destroy a Tesla.
Heck yeah.
For you. Yeah, how about that?